In your textbook, you should see a diagram or illustration that is exactly like this one or very similar to this one. This is a diagram which explains the water cycle in nature. Since this is a cycle, we can start at any point in the cycle, but I would like to start in our conversation today with water in the atmosphere. Water in the atmosphere is being held there at a very high rate of tension. You'll see some numbers here. In this case, it's minus 20,000 kilopascals. That kilopascal is a unit of measurement which is estimating the strength with which that water is being held, in this case in the atmosphere. If we were looking at this in terms of bars or atmospheres of negative pressure or soil, or in this case tension, we would move these two to the left, so this would be approximately minus 200 bars or atmospheres. Obviously, plants are not able to take water directly out of the atmosphere due to the high tension with which that water is being held. Once we get condensation or precipitation and this water is removed from the atmosphere, it falls as precipitation. It shows here precipitation or irrigation water. This water is striking the surface of the soils and or plants on that soil that grow in that soil surface. Some percentage of that precipitation will be intercepted or held up on the surface of this vegetation or plant material and be directly evaporated back into the air. What we are most concerned with in this conversation is what happens to the precipitation or water that strikes the soil surface. Ideally, we would have 100% intake, meaning that all of the water striking the soil surface would be taken into the soil profile. In many situations, that of course is not true, so this shows on this particular diagram a certain percentage of water running off or not being taken in by the soil. That could be anywhere from 0, if we had a 100% intake rate, up to as much as 30% under a very steep slope and or low cover, vegetative cover, and or high rainfall situation. The water that is taken into the soil is going to be transmitted or moved into that soil profile to some depth. Depending upon the soil profile depth and the amount of precipitation, we may actually see some water moving down deep in the soil profile and be stored down here below the effective rooting depth of plants that grow in that particular soil. And we're describing that here in this diagram as drainage water. That water not held or stored within the soil profile, but pulled down by the force of gravity below the rooting depth of the crop. This also sometimes is referred to as gravitational water. So we have, let's say, approximately 40 to 95% of this moisture that entered the soil, infiltrated, that is being held. We have a certain percentage of that which is going to be held by the soil against the pull of gravity and also against the pull of the roots of the plant.